So class question 4, we have a coherent light source that contains two wavelengths. 660 nanometer red and 470 nanometer blue. They pass through two narrow slits separated by a 0.3 mm, and the interference pattern is observed on a screen 5 meters from the slits. So this is our double slit. So the separation between the slit represented by D is 0.3 millimeter. So we can change it to SI unit 0.3 to the power of -3 meter. Then we form an interference pattern on the screen. So the distance from the narrow slit to the screen is represented by capital D is 5 meter. Okay. So we want to determine the distance between the first order bright fringe for each wavelength. So first order means our n is equal to 1. So we want to determine the distance between first order bright fringe for each wavelength. So let's say we assume for the wavelength 660 nanometer red, we form the first order bright fringe here. Okay, let's say we form the first order bright fringe for 660 nanometer red here. And then for the blue light, the first order bright fringe is formed here. Contohnya. Okay, dia terbentuk di sini. So, kita nak cari the separation or the distance between these two first order bright. So kita nak cari separation antara dua first order bright ni. So kita tahu kita boleh measure the distance. Kita boleh ukur distance daripada center maximum to the first order bright fringe. We call it as Ym. So kita boleh cari Ym for the blue light. Then kita boleh kira juga Ym for the red light. Okay, so we take the Ym for the red light minus the Ym for the blue light. Then we will get the distance between the first order bright fringe for each wavelength. So in order to solve this question, we have to calculate the distance of the first order bright fringe for the red light from the central maximum. Same goes for the blue light. So because it is bright, so class is bright fringe. So bright fringe means it's a constructive interference. So we are going to use equation 71, whereby Ym is m lambda d over d. So we are going to have Ym for red light will be m lambda red d over d minus Ym blue will be m wavelength for the blue light multiplied d over d. Then we put in the value. So first order means our m is 1. Wavelength for red light is 660 nanometer times 10 negative 9 nano. So the distance is 5 over the separation between the two slits is 0.3 to the power of -3 meter. So same goes for the Ym blue. We substitute the value. So the wavelength for blue light is 470 to the power of -9. The distance to the screen is also 5. The separation between the two slits is 0.3 to the power of -3 meter. Then you might pause the video to do the calculations. So I get this value is around 0.011 minus this value is around 7.83 to the power of -3. So we will get the distance between the two order bright fringe for both wavelength will be around 3.17 to the power of -3 meter or 3.17 millimeter.